In terms of the methodological contributions of your paper, what are the main things that you had? What are the main challenges that you have addressed? And how will you think that make an impact of this paper and in terms of like using these kinds of natural language processing models?
Okay, so Hebrew is a tough language. It's completely different than all Latin languages. It's considered a morphological rich language. And the main challenge in Hebrew is that you put a lot of words together into one single word that models should understand, okay? So for example, if in English you would say, he said, in Hebrew, it might be just one single word. If you say his pen, in Hebrew, it will just be one single word. So it's a very challenging for a model to break up the words and understand what is exactly said and what's the core of its sentence. So with that in mind, trying to borrow the architectural guidelines from Latin languages to the Hebrew language is impossible. Okay, you could, but you won't get an optimal model. So the main challenge in our paper was to find the best architecture or BERT architecture for the Hebrew language. We started with some hypotheses of what will work best for Hebrew, and since BERT models are extremely complex to train, we trained all different architectures on very small data set, the Hebrew Wikipedia data set, just to verify that what we think will work best actually works best. So that's the main idea of the paper, is to find the best architecture, and once we found it, we confirmed our hypothesis. We implemented the pre-trained model on a much larger set as like standard data sets for all different languages, which is the Oscar data sets, the dump of Google, and Wikipedia data set.